For our final project, we decided to make a ZedBoard calculator. This design took two 4-bit binary numbers by using the switches and performed an operation based on the values stored in a counter, controlled by the up button. The result was then displayed through the LEDs, and overflow was indicated by the leftmost LED. This is the overall implementation of our design. The 8 inputs are mapped to the switches, the selector is mapped to the up push button, and the outputs are mapped to the LEDs.
This is the principal design for a calculator. We have three operators, the adder, the subtractor, and the multiplier, as inputs to our multiplexer. This is the actual implementation of the calculator. On top of the multiplexer, there's overflow detection. Basically what it does is it compares the output of each of the operations with the final output of the multiplexer, and it compares that with the overflow of the specific operation, such that it detects when there is an overflow in the whole circuit. This is a half adder, which is the basic building block of our entire circuit. It's simply composed of an XOR gate and an AND gate, and all it does is it sums together 2 bits. And the half adder is used to make the full adder, which simply has 3 inputs and 2 outputs, and is used as the basic building block for the rest of the operations. And this is what the interface for all of the operations look like. It has 2 splitters that split the buses into inputs. It has the bit operator, which does the operation, and it has the concat, which puts it back into bus format. And this is the implementation of the 4-bit adder, and it's simply 4 full adders chained together. And the 4-bit adder is also used to make the subtractor, which simply uses the 2's complement of the second input in order to subtract. So the next operator was the multiplier, which is much trickier. So in order to figure out how to implement that, we first did the bitwise multiplication by hand to see how it did, and we sort of saw the pattern inside of it in order to figure out what sort of implementation we need to get the outcome we need. And here we have the implementation of the multiplier, which is basically separated into rows by each of the second input's bits. And the first input's bits are ANDed with those and put into full adders, which the least significant of which become the bits, and the rest of them wind up summing back into it. And here we have one of the rows zoomed up in, and we can see that it's basically the same thing as having a 4-bit adder.